So this week, what I would like to present is the how to design a manufacturing execution system using the distributed object-oriented technology. So the outline, the introduction, basic foundation, etc. So I will go through them one by one. Introduction, the background and the motivation why we need a manufacturing execution system. The manufacturing objectives is to have cost reduction, cycle time reduction, yield improvement, etc. So this is ordinary requirement of a manufacturing execution system. And the other two here, this is what I try to aid to this system, is the failure recovery and security certification. But anyhow, this is just an example. So what I really would like to teach you of this kind of technology is when you have a large scale object-oriented system, large scale software system, then I just try to demo how to use the distributed object-oriented system. I should say distributed object-oriented technology to design it. And of course, the very first step is to know the requirements of this system. And today, the system that I try to present, try to use, is the manufacturing execution system. So, of course, to begin with, we need to know the objective of this manufacturing execution system. Of course, that is the manufacturing objectives, and those are the objectives. And we should know these objectives first. Then, this is the background. I mentioned this several times that I try to use a framework design and using the COBA infrastructure as the backbone, and then try to design a system by using the distributed object-oriented technology. And you have already know what is the object technology and what is COBA. And I just try to use those concepts to design this system. And for the MES framework, we have scheduler, system manager, equipment manager, etc. And how this system works, how they can communicate with each other. Last week, I have already teach you the concept of COBA. Let's try to separate the interface and implementation. Did you remember? Try to separate the interface and implementation. Then, if that is the, if you know that, then if you would like to, for example, would like to have a new scheduler design, and of course you just need to stick to two copies the interface shown here. The interface shown here should be exactly the same. Then you can plug and play. You can plug out the original scheduler and plug in the new modules that you try to integrate into the system. So what we really would like to use is this concept. Then, now, just a second. Yeah. Okay. So motivation and purposes. Here, this is just an example. The so-called Holonic manufacturing system. Why I said Holonic here is just because this is something like agent-based. Holonic is a biomedical term. Holonic manufacturing system. Sometimes we call it HMS. And the characteristics of this kind of system will have intelligence, autonomy, cooperation, reconfigurability, and extensibility. So this is the characteristics of a Holonic manufacturing system. And of course, in order to accomplish this kind of requirements, what we need to do is to use the distributed object-oriented technology, and so that we can assign those functions to this system. So you see, this is the example. What I show you is the typical, or I should say it is a simple system for packaging house. And for this packaging house, we have the equipment. I should say equipment. The manual are the equipment, right? Then the equipment needs an equipment manager. Here we call it equipment Holon. Holon is some kind of agent. Actually, this is the equipment manager. So the equipment need an equipment manager to be the bridge to connect the equipment to the MES system. These are the MES system. Then the MES system we have a several Holon. That is for system manager. Then we have a WIP Holon, scheduling Holon, etc. You can think of this Holon means a manager. So this WIP tracking manager, scheduling manager, or equipment manager, etc. Besides this kind of functionality, we still need to have a material handling. The material handling, we have AGV here, robot, and ASIS, right? So those are controlled by a material handling controller here. And of course, in the system, we have a data warehouse. That is a database too. So this is a real implementation. So this is example, a typical example that what we really try to control is this system. But how we can write an manufacturing execution system? They can have this kind of operation. Actually, what we try to do, did you remember? Let me show you the other typical example. I mentioned that several times when I mentioned, sorry. Oh yeah, here. This is another example of MES operations. So did you remember we have equipment here and we have equipment manager, so that this equipment manager will be the bridge between the equipment and MES. The example shown here, the MES has material control system and recipe management with tracking as SPC, and so we have MES operation something like this. When you ship a cassette into an equipment, and this will have job in, processing, and job out, right? So in details, we will have something like that. When to begin with, we need to ask the MCS to ship a cassette into the system, so that he will check that if the FOB arrived, and then he will check that about the WIP tracking. Does this FOB, and the next stage is this equipment or not? If yes, then just track in. Otherwise, you need to reject this cassette, so that it will go to the other destination. So after the cassette has arrived here, then we need to check the WIP, right? Right. So after the FOB arrived this equipment, then he need to check the job in. In other words, to check with using the WIP tracking to check that this is the next station that he should be processed. If the answer is yes, then you just check it in. In other words, you will have a check-in process. Then not only check it in, you need to print the correct recipe from the recipe management. So the job, he will ask the recipe manager to download the recipe so that the job can be started. So after you have already downloaded the recipe, and then he will start to process, right? So collect data. Then during the manufacturing process, he will collect the data and send it to SPC to check that the quality is good or not. So of course he can use the SPC chart to show what's going on here. If everything is good, then he will let it go, let it proceed. If something wrong there, then you see he will check it. Will send an alarm to the alarm manager to see what's going on and try to cure it. If the result is good, then of course he can finish this job, and the job will be job out, and the hoop will be moved out to the next stage, right? So of course, after you move it out, then he will use the with tracking functions to check it, to track it out, and the hoop will go to the next stage. And this is the implementation and the job in. And of course, you can use the same process to do it. So this is the MES operations. But this is what we call it. It's a fab, semiconductor fab. While what I shown here, this is assembly house, something like SPIL 或是 ASE， 就是细品或是联电。我以前是跟细品合作 so this is the example. And actually, MES can be used by various kinds of companies, not only the fab, assembly house, even the TFT LCD fab or solar cell fab. They always have this kind of manufacturing execution system. So the functions are similar. So you see, for this equipment, we have an equipment manager to communicate between the equipment and the MES, and we have a web portal and scheduling portal, etc. So this is the requirement of this function, this system. So see, what are the basic foundations before design this system? The first one, of course, we need to know the definition of holons. And then we will use the MES. The holons, of course, I will. This is not very important for you to digest, to dig into what is holon. I will give you the concept. That's all. The most important is the UML, COBA, and the framework, and the design procedure. The holon just anyhow is a concept of agent, using the bio concept. That's all. But UML, Professor Hong has already teach you what is the object-oriented technology, and they will use the UML, this unified modeling language, using this language to design an object-oriented system. And COBA, I have already presented to you last week. And MES framework, this is what I try to tell you several times, and I will use it today. Then finally, you should know the development procedure for object-oriented system. For example, you need to do the OOA, object-oriented analysis, then object-oriented design, right? OA, OOD, etc. to design the system. And those design, how to design this one has been taught by Professor Hong. So I will go through them one by one. Holon. This is the basic foundation. I mean the holon. Holon, you see, holon is something like a cell. 就细胞啦 cell. So you see, a holon, a small holon can cooperate and become a big holon or medium-sized holon. A medium-sized holon can be grouped, become a big-sized holon, something like that. So you see, this is just some kind of bio concept. So you see, internal structure and rules. So you see, this small cell can communicate with each others, and they can cooperate with each others. So you see, this is super ordinary two parts, and they can communicate with the others, right? And you see, for this kind of, this is just a concept of agent, or you just can use this kind of elements to group them and to aggregate them so that they can become a large cell, a large agent, or large systems, so that they can cooperate with the other systems. Okay, and you see this one shown here. Each circle is a holon. So this is a material holons and equipment holons, etc. So holons can communicate with each other. And an example is actually for human being. We can use this kind of concept to describe a human being. So human being, you see, a human being has his eye, his hand, and he has foot, right? So when, for example, I would try to grasp an object shown here, then my eye will send a signal to my brain, okay? And the brain will ask my hand to approach this object and grasp it. So my eye is one of the holons, but brain and the hand, they can cooperate with each other so that I can perform this task. So this is that kind of concept. So when in MES the same, we can, for example, if I really would like to take a cassette from here and bring it to the equipment so that he can perform the wire bonding, etc. Right? So you see, this will be a holon, and this is a holon. Robot is a holon, equipment is a holon, and the equipment manager is a holon also. So you see, this AGV holon will go to ASIS and just try to load the cassette and then bring it beside the equipment. Then the robot holon will grasp the cassette into the equipment. Then the equipment will start processing, and during the processing, the signal will, the data, the manufacturing data will send through the equipment manager to the shop floor holon, and then, if necessary, send to the customer. Right? So this is some kind of cooperation. So they can use the holon concept to explain it. Okay? So this is, sometimes we call it it's some kind of agent. Okay. Then UML. I think you have already know what is UML. So we need to draw a use case diagram. If you would like to use the UML to design a system, so you need to draw a use case diagram, then a class diagram, state diagram, sequence diagram, and collaboration diagram. I think you should have already done all of them, right? 没错吧? Okay. Then COBA. I taught this last week. So what is COBA and what is ORV, right? And client side and server side. So those are taught to you. You should have this idea last week. And then the framework concept. I explained this several times, so you should know this one already. Then this is the basic foundations, how to design an object-oriented system. So you see, the basic foundations, you see, to begin with, we need to do the system analysis. So you need to correct and study domain knowledge. Did you remember last time when I present the equipment manager, we went through the same procedure. We need to know what is the requirement of equipment manager. So you need to study. You need to correct all the requirements of equipment manager, right? And you need to analyze all the requirements. So those are the system analysis. And after that, we need to do object-oriented analysis. So how to define a use case and identify each scenario using the use case, right? So use case, then the scenario, then of course we'll draw the class diagram, right? So this will give you the initial class diagram. The OOA, object-oriented analysis, will, the purpose of OOA is just try to know what you try to do. right? So this is just a simple design to define what you try to do. Then if you know these principles, then a step further is to do the object-oriented design. Then you need to do how you can implement it. So this is object-oriented design, and you will choose what kind of language, what kind of OS you would like to develop. For example, and if you just try to write an app, then you should know that you will use the Android OS or iOS, right? Those are different. If you try to develop an app for Android cell phone, then of course you need to use Android OS to develop it. If you try to let it belong on an Apple's iPhone computer, right? So you need to use iOS. So, but here, when you try to define your app in this stage, it's not necessary to worry about what kind of OS or what kind of language you would like to use yet. But when you try to design, really implement it, you need to do the object-oriented design. You need to consider which tools, which environments, implementation environment you are using. Then you need to follow that kind of rules. So you see, you need to find class relationship and their operations attributes, and you need to refine the sequence diagram because this is some kind of specific design. You need to follow the implementation rules of that environment, right? So finally, you will have a complete design, complete object-oriented design, the class diagram, and then after you finish the design, then you can code it. You system implementation. Maybe you will use the C++ or Java or any kind of language that is suitable for you to implement it. Then after you implement it, then you need to test it. And if really this is what you want, and this just can give you all the requirements. I should say, can satisfy all the requirements. Then of course the job is done. Otherwise, then you need to feed it back to see what's going on, and you need to change the requirements and go through from the beginning to refine it. So this is a basic foundation. So be careful. This is just a basic foundation for design an ordinary object-oriented system. This is not the procedure to design a distributed object-oriented system yet. Okay? So what I try to do, to teach you, is the distributed object-oriented design. For this one, it's just a basic foundation. I think Professor has already teach you how to do this. And this is just give you some kind of summary. But what I really would like to teach you is the distributed object-oriented system, because it's large-scale system. This is just a small scale. I should say it's just a component or a module, a single module, single object. A single object, then use this procedure to design. But it's a large-scale system, have several modules to cooperate with each other. Then, if you just use this one, it's not enough. You need to define the framework first. So this is just a basic foundation. So next one, develop the Holonic manufacturing execution system. This is a large scale system. Then how I can develop how I can develop this system is the following. So to begin with, we need to develop the procedures. Then of course we need to this is a large scale system, but still we need to correct all the design or domain requirements and analyze domain knowledges. Then we'll have this called, why I call it Holonic. Holonic means framework design. This Holonic design is a framework design. And this framework design, also these are the major steps. The first one is how to construct an abstract object model. then partition application, and then identify genetic functions. Those are the real step one by one, and I will go through it one by one. This is very important procedures, and you should know this one very well. So to begin with, you see here, this is the development procedures. This is really the development procedure for distributed object-oriented system. So this is really the one that I try to teach you now. So be careful. When I mention to you, when maybe during the final, I will, of course, this got to be in the final. Then you should know how to design this one. So we should have two flow chart, right? And this is the procedure for design, the development procedure for the large scale system. While this one is only for a small module object-oriented system, the regular object-oriented system. So don't be confused. Okay. Sometimes when I asking you how to design a large scale system, so some of the students just use this drawing to explain it. Of course, this is wrong. This is just for a small object, for a small object, just a single object only, or single module only. While this one is a large scale system. How I say so? You see, system analysis, to begin with, of course, we need to correct the domain requirements and analyze domain-ology. Then you see here, this is the framework design, the Holonic design, framework design, and we will construct abstract object model and partition. You see, we need to, because this is the very large scale system, and all the functions need to be partitioned so that we can design them simultaneously. So you need to, and of course, for object-oriented system, we always try to enlarge the genetic portion. So we need to identify the genetic functions among functional hormones so that we can use inheritance to simplify the design. And then, of course, we will design the genetic hormone and then design a Holonic messaging. That is the framework messaging. Then the framework of, okay, I will go through it one by one and you will know what's going on here. But this is really the design procedure for design a large scale software system. So this is the design procedure for distributed object-oriented system. So I'll go through it one by one. So how this is doing. Yeah. So to begin with here, those two, system analysis. Did you remember when I mentioned about MES and we need to know the manufacturing objectives? It was shown in page 5. For example, try to reduce the cost, try to increase the yield, right? Did you remember? So you need to know what we need to do because that is the basic requirement for MES. Then of course, this system and the requirements, one of the requirements is open interfaces because we try to have an open standard. So each one, if they would like to provide a new functional modules, and they can do so because it's an open interface, because the interface are known. It's that you can write an app, and for example, when you iPhone or Android phone, then you would like to write an app, and of course you just follow the interface. So that is some kind of open interfaces. So everyone can write an app and can download on the download to the cell phone, and he can do it just because it's an open interface. So you see this kind of open interface, this kind of technology, it has been very popular 20 years ago. Okay, not just now, just because at that time we don't have cell phone yet, but you see the same technology can be used. That is always all the object-oriented design. Okay, then the modularization. In other words, you should let all the functions be packed individually, so into several modules. So all the functions, all the unique functions, different functions will be in the different modules. Then it's kind of distribution. In other words, the functions will be distributed. For example, we have scheduler, we have with tracking, we have SPC, right? Those are different functions, different modules, and they should be distributed, and they are different functions, and they can be run simultaneously. And then configurability, in other words, we can have configurable. We can pick several functions together so that they can cooperate with each other. And you see the interoperability. Did you remember when we mentioned about we study about the COBA, and you will know the definition of interoperability. This is operable. Operability 那 interoperability 中文叫做交换操作性的。The interoperability means that when we have different modules and they can operate with each other, so this is interoperability. And maintainability, in other words, it should be easy to be implemented. And the last two, this is what I try to add, because I just try to demo that. Besides this one, and if I need to add two more functions here, then you just need to consider those two functions in the beginning of the system analysis, and just put those two functions in. Then because you have already considered those two functions, so after your design, then of course these functions will be built in the system. Okay, so you see, this is the what we call the Holonic design here, shown here. This is the framework design. So the first step is construct abstract object model. So you see, this is the object model, or I should say class diagram of an MES. So MES is a factory area. This is aggregation. So an MES will have a label, this operator. Material, something like the wafers, right? Or cassette. And equipment, you should have equipment manager, right? And the whip. So this is just a typical example. Of course, you may have scheduler and etc. I'm sorry, scheduler is here. You may have, for example, the SPC, etc. Right? But you see, this is the main role of equipment. I should say of the MES. MES should consist of a lot of equipment and a lot of wafers. That is the material, and we will have operators, and we need to track them. So we will have the whip. The whip is the work in process, right? So, but equipment, we have equipment manager. Holon means the manager. Equipment, we have equipment manager. This equipment manager will manage the equipment. And the material Holon is material handling system, material control system. We will handle all the materials. All the materials here means, for example, the AGV, SRS, etc. And the label, this is the label Holon. We will manage the label Holon, right? And besides these functions, we will have a shop floor Holon. This is the shop factory manager. It will control the whip Holon, equipment Holon, material Holon, etc. And besides that, we will have a scheduling Holon. Then this will dispatch job to all the managers. So you see, the shop floor Holon will control those 4 managers, and shop floor Holon will dispatch orders to the scheduling Holon, and then the scheduling Holon will dispatch jobs to all the managers, and these managers will control their elements. For example, material Holon control or manage the materials, equipment Holon will manage the equipment, etc. Right? And of course, we will have data warehouse. This will support all objects. So you see, after you understand the system requirements, then you need to construct the abstract object model of an MES, because now the example is MES. So you see, this is an example. This is the object model of an MES. Okay, so this represents this object. I'm sorry. So this object where it's an that class diagram is a class diagram of this implement. I should say this real system, right? So a factory consists of equipment and operators and materials and WIP, right? So and we have equipment Holon to control it, and we have WIP Holon, etc. And the scheduling, and the shop floor Holon will dispatch an order to the scheduling Holon, and scheduling will dispatch order to the AGV, etc. to do the job. But you see, from here, it's not easy to know the operations. It's not easy to know the message flow. But after you draw the diagram shown as in this class diagram, okay, then you will know that, okay, this gives you more information of the MES, how to operate the MES, how the operations of MES works, right? So this gives you more information. But this is just give you a data structure, or just give you the signal flow. It may be something like that, but this is some kind of static model. We should know the dynamic model also, so that will be presented by something like a sequence diagram. But I will go to that later. But you see, this is a large scale system. Too many functions will be performed simultaneously. So it's not easy to design this kind of system by a monolithic packaging， 就是一个大系统要全部把这个写完不容易。So that is the monolithic system, is large scale system. But what we try to do is try to partition the functions so that each functions can operate alone and but they still can cooperate or interoperate with each other. So you see, this is just after construct object abstract object models is shown here. Then the next step, see here, you see, we need to partition application domain into components. Again here, those are the application domains. This is the label, material, equipment, WIP, etc. So you see, we need to know that the functionality of that. Then we will partition all the functional modules into several functional modules, you see. So this is one of the modules. Material is the other, equipment, WIP. And the scheduling and shop floor are different. So you see, here we just try to partition application domains into components. So the entire application domains are divided into here is six components, right? So you see, after we partition this into 6 components, and we need to know if there are any genetic portions, genetic components. Because we try to use object-oriented design, we need to we need to have a design pattern for all the genetic functions, so that we can use inheritance to design it. So you see, after view this one, you see 1, 2, 3, 4. Those 4 are similar, right? So you see the next one. We need to identify the genetic functions among functional holons. And yes, we do have that kind of identify. You see, the class diagram is about the same. You see, those 4 modules are about the same. So we can just design a genetic holon, and this can take care of this can take care of the genetic portions of those four components. Then we just need to design a genetic holon, and those four can just inherit that genetic holon and just give them some specific functions of that specific modules. Then we will finish the design. So you see here how to identify the genetic functions among functional holons. You see, we need to know that this genetic holon will have an intelligence mechanism, search mechanism, security mechanism. Why I say so? Just because of the what we try to accomplish. I should say what we try to accomplish the system functions. What are the system functions? I should let you know. Yeah. Design. No. Just a second. Just a second. Yeah, here. I just said the system analysis here. Okay. We need to have all the functions shown here, right? We need to have interoperability, maintainability, configurability, and this security certification and failure recovery, right? And open interfaces. We need to have these kind of characteristics. Then, in order to do so, the genetic holon should have those functions. This is after we our observation. Then I find out that we should have the genetic holon should have this kind of capability. So you see, we need to have an exception detection and exception diagnosis so that we can have self-diagnosis. So this genetic holon should have intelligent mechanisms. And then you see, we need to have some kind of cooperation and reconfigurability. We mentioned about that they have collaboration or reconfigurable, right? You can group several holons together to accomplish a mission, right? And then how to find those group or how to find that partner so that they can cooperate with each other. So we need to have a search mechanism, and we have a security mechanism because we need to have a security authentication, right? So we have security certification. So we need to have a security mechanism. Then to do the security certification, data encryption and data decryption. So this is the basic functions we need to have in the genetic holon. Okay. Besides that, then you see, this is genetic holon is become an object now. So in order to design this genetic holon, then we can use the object-oriented design procedure to design it. So you see, we need to know the requirements of genetic holon and draw the use case diagram, sequence diagram, class diagram, etc. So for this procedure, because you have already identified a genetic holon, right? And this is the common requirements. Those are the common requirements of genetic holon. And of course, you will design through this procedure. And this procedure, of course, we can follow we can follow this procedure to do it because it's been an object. It's been a single function, right? Then this is the procedure for design a single function or single modules. So this is the purpose. This is the purpose. I mean, this one is used to design a single object. So you see, then to design this genetic holon, because this is a single object. So how to design this one? You see, we need to know the requirements of GH. So yeah, I'll give you a break. Then I will start to design the genetic holon. Follow these procedures. Okay.哦，你就记得把它剪掉啊。So this will show you the framework design, how to develop a genetic holon. So requirements of genetic holon. So this is the listing of all the requirements of genetic holon. So it can construct a message backbone for cooperation and communication purposes. So the genetic holon, if you have the digital holon, then he can construct a message backbone for cooperation and communication purposes. And then he can provide the mechanism for security, because we have a security certification functions, right? Then the third one is provide the ability of error diagnosis, and then provide the ability of searching the desired services, and finally provide the ability of establishing the database service for information storage. So you need to list down all the requirements. Then this should all be considered for designing the genetic holon. Then the next, so you see, according to the requirements, then you see next one you need to according to the object-oriented design procedure, we need to draw a use case diagram. So you see, with communication, construct communication backbone, search desired service, and security mechanism, right? So those use case diagrams are constructed according to the requirements shown here. Okay. So the next one, we need to design the sequence diagram. For the use case, after you have use case, you will draw all the sequence. Of course, this is just OA only. So you see the functional holon, how the functional holon can access the database. So it will through the holon kernel and holon configuration. So this just give you an example. So the detail you can check with the paper that I show you as the reference. And I think you should know this kind of convention or notation of UML here. And of course, so, and yeah, this is ON and OD. This just give you a final design. So you see, this is the OD, the class diagram of genetic holon. So this is holon kernel. The holon kernel can construct COBA and can use the security mechanism, and can manage the local database, and can use the knowledge base, right? And what are the functions? This is after detailed design. Then I show you the result here. So if you would like to see the details, just please check the reference that I attached in the last page of this presentation. So you see, this is the holon configuration. But after you know you have designed this kind of OD diagram, you can draw it more beautifully. You see, this is the more beautiful diagram than this one. You see, the class diagram is something like that, but we can redraw it to show the genetic Holon internal architecture. So you see the Holon kernel communicate with the security mechanism, local database, knowledge base, and the COBA interface. So you see, so this is what I show here. You see, communicate with the security mechanism, local database, knowledge base, and the COBA interface. Okay, so those two are just use different diagram, but they are the same things. Okay, so they can communicate with each others. Okay, and then so we need to design the Holonic message. It means you need to write down all the framework messages, so sequence diagram and collaboration diagram, etc. So, and just a second, I'm sorry. So after finish the genetic Holon, because this is the Holonic design development, the genetic Holon. This is we have already finished the design of the genetic Holon. Then after you have the genetic Holon, then we need to design all the framework messages. In why we need to do so? Did you remember what we really try to do is using COBA to design the distributed architecture. Then in order to do to design it, then we need to separate the interface and the implementation. Now, but the interface will be defined by all the communications among them. So we need to define the Holonic messages. That is the framework messages. And here, just give you the two examples: fully automated Holonic messages and the semi-automated Holonic messages. Why I said fully automated is just, did you remember the second week I show you the manufacturing portion and all of the scenarios just automated. So that is, so using that kind of scenario, and we can write down all the sequence diagrams. And using the sequence diagram, we can convert it into collaboration diagrams. What I try to say, did you remember? Maybe you I just try to refresh your memory. So you see, let me show you what's going on here. Yeah, manufacturing portion. Did you remember what I showed you last time? So we have this
在左边的空格填入 order ID, company name, type ID.
Did you remember this sequence? This is what I call fully automated scenario.
即可按下 Present Order 按钮，将订单送至 company 端。从画面我们可以看出，已成功地运送晶圆到 company 端了。我们可看出 Mace 从没有订单状态转换到开始加工的状态。在下面我们将会看到一个现场监控的画面，我们将之命名为 Real Time Shop Flow Control Panel， 简称 SFCP。在这里我们可以看到 ASRS 的状态由 Waiting Order 变成为 Retrieving， 并可由黑点察觉 AGV 的实际位置。当我们按下 Deliver Wafer 按键的时候 ，ASRS 以及 AGV 也就开始执行他们的任务了。
Yeah, that's it. So let's just show you. This is what I mean about the. I'm sorry. fully automated scenario. So the fully automated scenario, then what will be the sequence diagram? Let me show you what's going on here. You see, fully automated framework message sequence diagram. So you see, we are external user, and we have SharpRow Holon, scheduling Holon, ASRS, AGV, etc. Right? So this is present order. So send order information to the data warehouse. Then dispatch order. Did you remember what I show you? The movies. He will dispatch an orders to the scheduling Holon, and scheduling Holon will give the get the whips and get item masters and do scheduling, do dispatching, the dispatch job to the ASIS and to AGV, and then the robot, and then did you remember what I show you? The movies, right? So all of the events, all of the movement should be defined here. Did you follow me? So I just mentioned to you that, show you the picture, right? So you need to follow all the scenarios, all your imagination, how this system can operate. So you need to write down all the class, all the objects. This is shop floor, scheduling, ASIX, etc. And what will be the message? What will be the sequence? And draw down in details. So this is just half of plan. We have the second one. So you see continued. Then you need to draw down all of the sequence diagrams. Okay? And then you see Professor Hong teach you what is the sequence diagram ready, right? Then after you have the sequence diagram, you can use the tools of UML to convert the sequence diagram into the collaboration diagram. So that tool can do it automatically. So you see, we have these objects, for example, shop floor Holonic, scheduling Holonic, ASIS, etc. Rows 1, 2, 3, 4, 5, 6, 7, 8 are shown here. You see, 1, 2, 3, 4, 5, 6, 7, 8, right? Those 8 objects are shown here. But you see, all of the messages, IOs are shown, all messages are shown here. Okay, so if, for example, the equipment manager will accept a dispatch job from the scheduler, and he will send a finished job to a robot, and he will send the status to the data warehouse, right? And of course, the whip column, what the whip column will do, and he has input and output. So after you finish the design of sequence diagram, then you can use the collaboration diagram to convert. I should say you can use the UML tools to convert the sequence diagram into the collaboration diagram automatically. So this will show you all the framework messages. For example, if you would like to design the scheduling Holonic, then all of the interface messages are shown here. And if you would like to design a whip column, then all of the interface messages are shown here. And this interface messaging, why we need to have this one? Because when we try to use COBA to communicate with each other, we need to separate the interface and the implementations. So this shows you all the interfaces, right? So this will identify all the interfaces shown here. Then after you know the interfaces here, and of course if you know the basic requirements, and then you know the interfaces, then you can design each columns, each module simultaneously. You can design this one, that one, right? You see, totally this has 8 objects here. Then you can have 8 programmers to design everyone here, each one of them. So you have 8 operators, and I should say 8 programmers. They can design each function simultaneously because they know the interface here and the requirements of itself. So they can design simultaneously. So this is some kind of distributed design. And because after the design, because the interface has been defined very clearly and very accurately, so after the finish the design, then we can plug in the framework and let it run automatically. So you see the next one, you see. Now this just show you the semi-automated. So if you know automated, then it's not necessary to worry about the semi-automated. Why I say semi-automated is because if we don't have AGV, then operator need to carry out need to carry the cassette or the magazine by itself. Okay. So you should know all of these kind of design. The semi-automated means some of the jobs are performed by human beings. So this is semi-automated. And of course, semi-automated, we can have this Holonic design too. So you see, this then after we define all the framework messages, then we can use this kind of COBA infrastructure to define all of them. You see, we have already designed the genetic holon, so he can inherit the genetic holon, right? And so he can run. I should say he can, for example, if you would like to design the scheduling holon, then you just inherit the genetic holon and then add in its own functions, specific function, and if you finish the design, because you have already know all of the interface framework, interface messages shown here. Okay, so you see, so now I'll give you the example of design the whip holon, because I have already defined all the framework messages, and you see, so the whip holon. So here, if we would like to define a whip holon, again, then the object-oriented design procedure will be used. And then you see, so we need to know the requirements for whip holon. Then we will do the OA and OD. So you see, we need to know the requirements of whip holon. So these are the functions or specific functions of whip holons, or I should say all the requirements of whip holons. So it's real-time update and track by process and provide information for users. Ability, you see, then we have ability to access database and open interface, error recovery, and security certificate. And be careful here. These 4 functions, okay, those 4 functions are generic for all the holons, right? So we can inherit the genetic holon and then just add those 4 functions. And then we finish the design. This is the purpose of define. I should say this is the purpose for design the genetic holon first. Okay, so you see, and the Holonic message, the whip. This is the whip holon. So you see, we will identify this module and we will check all of the interfaces shown here. So this interface is shown got to be exactly the same as what we shown here. You see, oh no, this one. So you can check with it. Whip holon is here, right? So what's the interface among the whip holons and all the others? So this scheduling and warehouse and ASRS, etc. Right? So you just grasp the whip holon shown here. So the whip holon and just have 4 other objects need to communicate with the whip holon. So you will define all the interface messages shown here. So next one, of course, you need to draw the class diagram. So you see, this is we have this function: track out, track in, provide information, and handling exceptions. Okay, and you see we have genetic holon because so how to implement this one? Because 4 of them, four of the functions will be implemented by the genetic holon. I just mentioned to you, right? These 4 has been implemented by genetic holon. So it's not necessary for you to redesign this one. You just inherit the genetic holon. You can have those 4 functions. All the other 4, of course, is a specific function of whip holon. So you should design by yourself. So you see, we have 4. 1, 2, 3, 4. These 4 functions, but the other 4 just use the genetic holon. Just inherit from the genetic holon, and you can do so. So of course, then you need to draw the object-oriented analysis. I mean the sequence diagram. Then another sequence diagram. So then this is OA class diagram. You see, we need to inherit the genetic holon, right? So that those genetic functions, those 4 genetic functions, can be implemented easily. But you still need to inherit. I should say you still need to design the other 4 functions, right? That is the specific functions for whip modules, and this is the OA stage. But you see, then we need to design an OOD, creating new whip object for OOD, object-oriented design. This you need to worry about the real functions and what kind of implementations you are using. So we will have all the functions, all the functions shown here. So the tracking, this one is create new whip object, and next one is the regular tracking, and then is tracking operation, then user login, and finally this is the OD diagram. So you see here is the generic Holon. We just inherit the generic Holon, and you see this is Holon kernel, and the COBA interface, security, local database, etc. Right? Those are the class. Those are the class diagrams of the generic Holon. So you just inherited it. Then you will have those 4 functions, and the other 4 functions you need to design for the whip Holon. Right? So you just finish the design. So after you finish this design, because we have already considered all the framework messages, if you remember, we draw the sequence diagram and convert it into collaboration diagram and consider all the interfaces. Then of course you can plug and play, because you design all of this, follow the interface. Then this is the implementation. So we separate the interface and implementation. Not only the whip Holon, but also the scheduling Holon, the equipment manager, all the others can design like this way. So you can design all the functional modules simultaneously, right? So this is distributed object-oriented design. So you can have a team to design the system simultaneously. So it's not a monolithic design. This is a distributed object-oriented design. Okay? So of course, if you try to have a state diagram for whip Holon, then we will have a state diagram of whip Holon. This is just the class diagram, show you the data structure. But you see, this will show you the state diagram, what will be the state and how it works. So the state diagram just the same, as you said, the state diagram just show you the dynamic behavior. And here we have a, and you see the whip object life cycle. So this is the state diagram, right? Whip object life cycle shown here. Then we have object life cycle. This is the state diagram of whip Holon. The whole whip Holon is something like that, but this portion, whip object life cycle, is shown here. This is whip object life cycle. So you see, we have this input and those output, right? So create whip, then delete whip. So I'm sorry. So you see, after we have this one, then we will create a whip. Then after finish it, and we will delete the whip. So this portion, just because it is very complicated diagram, so I just use 2 diagrams to show it. But this portion is here. Okay. So this is the whip object life cycle. So just imagine what kind of functions you would like to implement it into this module, and just draw it and put all of them together. Then this state diagram and all the class diagram and all the collaboration diagram and can be considered. And if the design are good, then of course you can convert this one into the programming language and then finish the design. In other words, into the coding, then you can finish the design. Okay, so then after you finish the design of a functional Holon, The functional Holons not just have one, you have several functional Holons, right? But you can design it simultaneously. So you see when we design a functional Holon, that's here. You can design all the functional Holon there. Then after you finish all the design, then you can plug in all the functional Holons into the framework so that you can let it run, plug and play. So you see, so implementation and system integration, right? So do the implementation and system integration. So of course, when you try to implement it and the implementation and system integration, then the system deployed architecture, you should know how to deploy the system. Then the functional Holons implementation procedure and application construction with special with system integration. So you see, so this is the implementation and system integration. After you have the system, then of course we will use the system to control these real systems. Then how it runs just the same as what I show the movies. Did you remember? The movie actually is running under the MES that's designed by our team. Okay? So let me give you some summary. So this is the design procedure. So to begin with, we need to correct all the domain requirements. Of course, these domain requirements are the MES domain requirements. If you would like to design a supply chain, then you need to correct the domain requirements of supply chain. So after you correct all the domain requirements, then you will analyze domain knowledges. Then you will construct the abstract model. Did you remember? I have already drawn an MES object model, right? So you need to draw an MES object model. Then after you have that object model, then you will do the partitions. So the partition cannot be too large, it cannot be too small either. Because if you have too many partitions, then the objects are too small, then the communication between them is too heavy. So it's not a very good design. But if you didn't partition it, then a very huge object, I should say very huge modules, sometimes it's not easy to maintain. So you see, it's better to partition the domain into functional components that has its own real functions. For example, the scheduler and WIP and SPC. So they are specific and they are independent. So you see, you need to partition them first. So after partition them, then you try to identify the genetic portion of them. Because we try to use the object-oriented design, so you need to identify all the genetic portions so that he can be implemented efficiently. Because you just need to design the genetic Holon once. All the others can inherit it and to finish the genetic design simultaneously. So you see, when we use the WIP Holon as an example to design, then we have 4 functions. For example, how to construct the COBOL backbone and how to interface with the database and how to do the security check. All of them are the genetic functions. And because you have already got the genetic Holon, you just inherit it. Then that's it. So you see, after you identify the genetic functions, then you can develop a genetic Holon. Follow the object-oriented system design, OAOD, right? You should know the genetic Holon's requirements, and after you know this requirement, you can define. You can develop these Holons and these genetic Holons. So after you have these genetic Holons, then we need to define all the framework messaging. So in order to define all the framework messaging, and you need to the framework messaging, then you need to draw the sequence diagrams in details. What kind of sequence you would like to design and what kind of sequence you prefer. You need to draw the sequence diagrams, right? And during preparing the sequence diagram, you will identify all the objects, right? what kind of objects you will use. Then of course among the objects, then they will have the messages go forward, backward. Then after define all the sequence diagrams, we will convert the sequence diagram into collaboration diagram, right? After you have the collaboration diagram, then it will clearly define all the interfaces among all the holons, right? So if you know all the framework messages, then you can define this framework. Because the framework, why we need to define this framework? Because we need to define all the interfaces among the modules, and because the interfaces are defined, then we can use we can define all the functional modules simultaneously, right? We can, for example, the whip holon, then you need to identify all the I/O, all the interface messages among the whip holons. Then you need to specify all the requirements of whip holons. Then again, follow the object-oriented design. Use the OAOD. Then you can define the functional holons based on the generic holon. And you see this is the functional holons design and implementation. You will design all the functional holons simultaneously, because you know the framework message among all the holons. So each module has its own interface messages, and each module you need to know their specific functions, and then you can design it based on the generic holon, because generic holon has already give you the basic functions. So after you finish all the functional holons, then you can construct applications and do the testing. And finally, you will have the integrated system and test it, because it's been designed by the COBA infrastructure and all the interfaces are defined clearly. You can plug and play. So this is what I tell you. Okay, what I teach you. So this week. So let me show you. Here, implementation and system integration. This is what I show you here. You see, we try to integrate the system shown here, and this is the functional holon implementation procedure. You just check it. You see, this is just the COBA framework. You see, genetic holon development, then HMES framework. And you will have just convert IDE to Java. So you see this is the client stub server skeleton. So you can combine. Just show you the implementation is something like that. But anyhow, right now it's easier than this one, because using the SOAP, using web services, you just define the WSDL web services define language. Then you can communicate with this very easily. So this is about 10 or 15 years ago method, I should say systems. Now, if you try to define or design this kind of system using SOAP or with web service, will be a lot easier than this one. So you just know this concept. So this is not a big deal. What you really would like to know is how to specify the interfaces, how to specify the framework messages, and how to design it simultaneously. Okay, so this is just to give you the integration, how to integrate those three objects simultaneously. So you see, this is scheduling holon, whip holon, and common database. So scheduling holon, a scheduling manager will try to get whip status through the information manager, and this information manager will send a query through the whip manager, and the whip manager knows that you are asking for some information. Then he will check that if this whip exists or not. If yes, then try to get it. If no, then he needs to get the information through the database. So this is just a simple example for you to test the integration. So summary and conclusion. So you see, what I really try to compare here is between the MES and Holonic MES. It just gives you some kind of idea, but sometimes right now we have a better technology now. But just let you know that legacy MES, this is centralized MES, and ordinary MES framework is distributed object oriented. And here, what I present here is Holonic. Holonic is just using the Holon concept to it. So what really is just the security certificate and the failure recovery. So you see this no, this yes. But what really you need to know is those two portions. For centralized system, for example, IBM has a centralized system called Poseidon. They have a MES called Poseidon. That is the old version of MES. That is centralized. But now they have LCD view or SI view, etc. That are the framework design. So this is distributed object-oriented system. So open interface is no, is yes. Modularization is yes, is high. Interoperability is high. Computation is high, right? Cost, something like that. So you just notice when you see here, legacy system, promise, work stream, right? Etc. And the framework is SI view, factory works, etc. So summary. So here I present a new concept of developing new generation MES and manufacturing execution systems. So this provides a systematic procedure to develop Holonic manufacturing systems. And finally, demonstrate the flexibility and the capability of HMES by design and implementing a weak problem. 好棒！哎，等一下。